Hello everybody, this is Mr. Longo here, and in this video we are going to work with sinusoidal application problems. So, crucial skills you must have are from the last video we did, where we were using our graphing calculator to evaluate and solve different trig functions, because the purpose is to be able to do problems like this. So, what we are going to do here is we are going to carefully read a word problem that suggests a sinusoidal type of graph. And it is extremely crucial that you read carefully and set up the correct picture and information. Because if you don't, you're going to write the wrong equation. And if you write the wrong equation, you're going to answer the wrong type of questions. And it's just going to snowball from there. So, read carefully. So we're going to be working with a water wheel shown below that rotates at 6 RPMs, so 6 revolutions per minute. So when you start your stopwatch, 2 seconds later, point P on the rim is at its greatest height. And now we are supposed to figure out a way to model this, where the distance d in feet from the point P, which is how far above the surface of the water it is, over t, which is time in seconds. A lot to take into consideration. So, when you are working with these kinds of problems, we need to do a few things. We need to talk about the start and stop, and we need to also talk about our crest and trough. So, for that, it's probably easiest to start with the fact that if we look at this, it has a 7-foot radius, which means from top to bottom of this wheel is 14 feet. However, we can see here the center of this circle is 6 feet above the water. So if we have a radius of 7, our lowest point, or our trough, is going to be at a -1. And the highest point, our crest, is going to be at a maximum height of 13. And of course, our node right here is at 6. Now, that information right there is going to help us write our equation. Now, also, you have to keep in mind that the radius in this situation is our amplitude. And that's going to be 7. Now we need to discuss the start and the stop. Now, at times that's tricky. So what we want to do is think sinusoidally. We're going to think about sine and cosine. So we need to start at either the node or at the top or at the bottom. Now this says 2 seconds later, point P is at the top of the wheel at its greatest height. So we are going to want to start with a time of 2 seconds. And then we're going to have that less than or equal to t, which is less than or equal to, when do we stop? Another thing you need to think about. This says 6 revolutions per minute. Well, if there are 60 seconds in 1 minute, and this happens 6 times, each revolution takes 10 seconds. So remember, when we're working with sine and cosine, we want 1 cycle. So if we start at 2 seconds, 10 seconds later, we are back at the top at 12 seconds. Okay, now pause and wrap your head around that. 2 seconds later, we're at the top. 10 seconds after that, we're going to be back at the top. That's why we go from 2 to 12. Okay? Now, we're going to have to do some solving. Now, again, this is where you have choice. You can do this in degrees, or you can do this in radians. It really doesn't matter. The first thing we want to do is subtract 2 from both sides, and that's going to give us 0 is less than or equal to t minus 2, which is less than or equal to 10. Again, proof right there. 10 seconds is how long it takes. Now remember, we want to get this back to 2 pi. So that would be our 2 pi divided by 10, giving us a b value of pi over 5. So to finish writing this part of the equation, we are going to go from 0, which is less than or equal to pi over 5 times t minus 2. So we have a t minus 2, which is less than or equal to 2 pi. Okay, now remember, this came from the writing equations video, where that part is crucial. So now we are going to give a little sketch of this sinusoid. Okay, so we have something that looks like this, 2. And then remember, we've typically gone 5 total tick marks, and this one we're going to end at is 12. Now, you can go ahead and count the tick marks along the way. You can find averages where that's going to be 7, and this is going to be 4.5, and this guy right here is going to be 9.5, or you can remember to go back to your period and just divide that by 4, and it will give us increments of 2.5. That's how we go up. Doesn't matter. Another thing you have to remember, we are starting at the top, and then we are going to go below the surface of the water, and then we are going to be back at the top. Now, those numbers are very important, but this is what one cycle looks like. And then, of course, we have a node, which we know is at 6. And then we have a height of 13 after our amplitude of 7, and a bottom or minimum height of a -1. So, what we have right there is a nice little setup for our graph. So, since we are starting at the top, that is going to make this a positive cosine graph. And we have everything else in place. So all we have to do is write the equation. So our equation is going to be d is equal to positive 7, because this is a positive cosine with an amplitude of 7. And then, of course, cosine. Now we have the b and c part of the equation that we wrote up here. So we are going to be at pi over 5 times t minus 2, close our parentheses, and then remember our node is at plus 6. Now everything that just happened right here is crucial. This is an absolute necessity, because again, if you have that information incorrect, everything else after it's time to type in our calculator is going to be wrong as well. So, but that's it. Once you have that, the rest is easy. That just goes back on our old video. So what does d is equal to a -0.5 mean? Well, don't say it means the minimum distance or explain in words. -0.5 means that we are 0.5 feet below the surface. Okay, and because we're going to ask you another question about that in a minute. So make sure you explain 0.5 feet below the surface, and you can even get more descriptive and say the surface of the water. That works too. But now we're going to ask a question: how many times in 1 minute will the wheel be at a distance of -0.5? Well, we have to think about the wheel and the water. It's going to hit -0.5 on the way down into the water, and again on the way out of the water. So it happens 2 times per revolution. So remember, we talked about how many times it happens. So if this is 2 times per revolution, and in the original part of the problem it says it does 6 revolutions per minute, we just multiply that by 6 times, and it's going to be at that distance 12 times in 1 minute. Okay? Now the last section, this is where we were using our start and our y1 and then substitute 5.5, or using the ask feature of our table. Either way you look at it, all you need to do is use your calculator and evaluate this function at 5.5, 15.5, and 0. And you would just type it into your calculator and you should get 1.886 feet and 15.5, which is another 1.886 feet. And at time equals 0 when this starts, you were at 8.163 feet when this got started, which takes me to a very important part of this problem. When you were typing this into your calculator, there is a good chance you made this your x minimum and you made this your x maximum. Now again, these are the skills that are required from the previous video. However, one special note I'm going to tell you, you still want your y minimum your trough. You want your y maximum your crest. You want your x maximum the 12. But for word problem purposes, always start your x minimum at 0. For parts like that, in case it wants to know what was the original height, you want to go back to 0. Okay, now that's the last point I have for this video. So again, I know that there is an additional example to this set of notes. However, this one example alone took over 11 minutes to talk about. I am just going to post that in the answer key on the website for you to check to see if you did the second example correctly. All right, this is Longo and I'm out. See you, bye.